Yeah, and so today I will be talking about minute physics. And I've called the talk Minute Physics and the grand unified theory of YouTube videos, because we have to have a grand unified theory in here somewhere. And if you want to check out the videos at any point during or after the talk, you can go to youtube.com/minutephysics. I recommend after the talk, but in case you get bored, it's perfectly okay. And this talk will be in this clicker isn't working. This talk will be in 3D. No, that's just a stupid film joke because I'm at film school. But this, I'm led to believe this is the first Sci Colloquium. So I hope that future Sci Colloquia will kind of allow us to converge onto the perfect Colloquium and fix all the errors that may appear in this, this first version. So today what we're going to talk about, I'm going to go through a little bit of history and background of minute physics and of YouTube and how it works for those of you who don't know much about it. I didn't know anything about it until about 8 months ago, so I'm new to this thing as well. Talking about effective communication on and off the internet. And this is where we'll actually look at some case studies of some videos that are fun and good and some that are not so good, and for various different reasons. And then I'm going to talk a little bit about just a few thoughts on teaching physics that I've kind of come to realize over the course of the last year or so. And of course, if you have questions at any time, don't hesitate to ask, shout out, tell me to slow down or to clarify, whatever you have, please. So without further ado, a brief history of minute physics. So first, what is minute physics? Well, Neil talked about it a little bit. This is what it looks like fairly recently. It's a YouTube channel. It's basically a page on YouTube that that I upload videos to, and people can watch them. And the videos are all about a minute long, minute to a minute and 30 seconds, plus some stuff at the tail end. And they're all about topics in physics. And let's see what's next. Now, the thing is, like this is a very kind of polished and more recent view of minute physics. And the question is, where did this come from? This didn't just appear out of the ether. So it kind of started back before college, but even in college, I was doing filmmaking. This is a Star Wars fan film that I made at Grinnell. And Grinnell was great because it was a liberal arts college, so I had a lot of fun doing things that weren't just focusing directly on math and physics. But it was a lot of fun to be able to come to Perimeter and focus entirely in the Sci course, entirely on physics all the time. As you can see, we were very productive in in our physics studies. But more seriously, we did spend a lot of time, and we taught each other differential geometry, courtesy of Manny the Manifold. And I felt safe enough to be able to play around with some animations in my Sci thesis talk, which were really just for show and didn't help that much to explain what was going on. So after I left Sci, I kind of took some time off. I wasn't sure if I wanted to do a PhD or not. I gave a talk at Grinnell College, where I went back there, and gave a talk, and that was kind of, because it was a public lecture and mainly for undergrads and public, I felt like I had to really boil down. I couldn't talk about general relativity the way physicists talk about general relativity to each other. And so that was really a seed and kind of an inspiration point and jumping off point for minute physics that was, at this point, I didn't know it was yet to come. Some of my other inspirations have been, of course, XKCD, which is a wonderful webcomic. If you're not familiar with it, I highly recommend it. And my next slide is blank. Oh, yes. Other things that influenced kind of my thinking before I even realized that I was going to do minute physics. Khan Academy is, it's a series of videos. There's there are thousands of them now. It's about a guy named Salman Khan who basically sits with a digital notepad and writes down lectures on all manner of topics in math and physics and biology and economics. And it's a great resource online, free, if you need access to university kind of lectures. But let's be frank, it's really boring. RS Animate has done another great series of little videos. They basically take TED Talks or similar kinds of talks and do whiteboard drawing animations to them. So that was really inspirational to me. I have some issues with RSA, which we'll talk about later, but their style kind of inspired me. And then, of course, things like Radiolab, which is a NPR radio program, which at first glance doesn't seem like it might have much to do with this, but they talk about issues in science and other kinds of critical thinking and really cool stuff. And it's an incredibly well-produced program. It's a pleasure to listen to and really cool. So those were kind of some big influences or things that I was thinking about when I started Minutephysics. But before other than the one video which I made and sent to Neil like September a year ago, I didn't do anything with Minutephysics. I didn't know anything about YouTube until I started working for these guys called Freddie W. It's a YouTube channel. They're now the 6th biggest YouTube channel. They have like 2.5 million subscribers. And I do special effects for them. I still work for them. And they kind of like, I just learned by osmosis of being around them because they know the business ins and outs of YouTube like no one else. And that's how they've managed to get so big. 2 years ago, they didn't exist. So now they're huge. So just to give a sample of what that is, I'm going to play just a short clip from one of their videos. And I did pretty much all of the special visual effects in this clip, almost all of them.
Boss, I roll with the Wong gang now.
Hold on, I got it. Update! No, why? It has to restart! Are we fucking just halfway done? Don't worry about it. I'll buy you some time!
Okay, so that was for Cowboys and Aliens. That was the director, Jon Favreau. He directed Iron Man and stuff. This is the kind of fun stuff you get to do when you're like in Hollywood. But it's also, it's not, I have this reservations about this kind of stuff because it feels like you're just doing, stuff that's kind of fun and people watch it, but what is it giving to the greater good of the world? And a lot of YouTube channels are like that. They're just there for kind of the instant gratification and quick. The whole video is like 3 minutes long for that. So that's basically what these guys do for almost every single video is just a gunfight. So it may seem original now, but when you watch like 30 of them, and when you do the muzzle flashes frame by frame for 30 of them, it's a little bit more tiresome. So I thought maybe, well, let's try doing something like this in physics. And so I got in my corner of my bedroom and set up a light and a camera and a tripod and started drawing. And I basically decided I had a lot of free time, well, a lot being 2 months of free time before school started this fall, and so I said, well, what am I going to do to fill my time? Do some drawing, do some physics, and I did one video a week for the 2 months before school started, and this is, what came out of that. Now, the thing about YouTube is that it's like a world in and of itself. It's the highest traffic site on the internet. The second highest site on the internet is m.youtube.com, which is their mobile site. So basically, they're huge. And the great thing about, or the power of the internet that you get from being on a site like YouTube is you get to work with other sites like Facebook, Twitter, and Google+, and interface with them and bring people who are like they're diehard Facebook users. Then you can connect with them on YouTube, or people who only use Twitter, or vice versa. So you can get audiences to watch your content from wherever they may be most comfortable. And so then the question is, like, where does Minutephysics fit in with all of this? And you kind of have to start from scratch, which is what I did. And the way that people measure things on YouTube, measure success, basically, is by subscribers, not by views, because somebody can upload a video of their their like little kid who's high on drugs from the dentist, and it'll get like 1 million, 10 million or whatever views. But the next video they upload, no one's going to watch. So in order to be viewed kind of as a success, you have to build a relationship with your audience. So when I started Minutephysics at the beginning of July, and I did the 8 videos until school started at the beginning of September, there was kind of a slow growth. The scale of this chart kind of misleads the fact that is about 3,000 people subscribed to get notified each time I put up a new video by the beginning of September. But it wasn't a ton. But the thing is that you have to be kind of committed and do this for the long haul, and then you'll see payoffs. Because in September and October, I started to get picked up by sites like New Scientist, IO9, Gizmodo. The Nobel Prize is somewhere in there, and I was really lucky to have just interviewed Sean Carroll on the topic for which the Nobel Prize was given. I didn't know this in advance, of course, but it was just luck, and I pounced on that. And then things like you get featured on the front page of YouTube, and life gets really nice for a day or two, and then it goes back to normal a little bit. And this chart is, I made this chart like, 3 or 4 days ago, and it's currently out of date because I'm almost at 130,000 subscribers now. So things happen very quickly on the internet, is kind of the point. But you have to be committed because they happen slowly at first until it blows up. So yeah, in a similar vein, this is a slide from, I don't know, 2 weeks ago, when Minutephysics just broke into the top 1,000 most subscribed channels on YouTube, and now it's almost in the top 900. So enough about Minutephysics. I don't like talking about myself that much, so we'll talk about general communication on the internet. And a lot of people think that the internet has caused people's attention spans to get shortened, and there is a lot to be said for like ADD on the internet. But I think that a lot of what's actually going on is the fact that you have the difference between a captive and a free audience. You know, if you're sitting here in this room, lecture room, technically you're free to get up and go, but people are going to kind of look at you sideways if you leave in the middle of the talk. So you know, you're a captive audience. On the internet, however, you have this option, which a lot of people tend to use, and if you can see it up there, let me go click on this X. Oh. But anyway, if that doesn't happen to you, you know, you're free to leave, basically. And that's the thing with the internet. You need to make content that is appropriate to what you're talking about. So if you have 5 minutes worth of content to talk about, you talk for 5 minutes, or make a 5-minute video. If you have 10 minutes worth of content, make a 10-minute video. If you have, 5 minutes worth of content, you don't make an hour-long video that no one wants to watch. So make it things appropriately sized. And a really good example of this and how the internet is not just ADD is the Star Wars Episodes 1, 2, and 3 reviews by Red Letter Media. And they are each 90 minutes long. They're like 9 or 10-minute segments of this one guy just watching clips of the new versions of Star Wars and commenting on them. And they're hilarious. They're amazing. People watch them all the way through. They're actually really educational as well if you want to learn about how to make successful films and how to make unsuccessful films. So this, to me, is a great example of the fact that the internet doesn't just cause people's attention span to lower. It just gives people the option to go to something else when they get bored. And when you're boring them and you don't have them stuck in this room with you because they decided to come to a colloquium that had an interesting title. So now we're going to start a little tour de science videos on the internet. These are some that I've looked at a lot, some that I watched before I started doing Minutephysics. In fact, most of them. We'll start with Khan Academy. I'm just going to play like a 30-second clip and give you the idea of what Khan Academy is all about.
What I want to do in this video is think about the two different ways of interpreting lowercase g, which, as we've talked about before, many textbooks will give you as either 9.81 meters per second squared downward or towards the center, Earth's center, or sometimes it's given with a negative quantity that signifies the direction, it was essentially downwards, negative 9.81 meters per second squared. And probably the most typical way to interpret this value as the acceleration, so let me write acceleration due to gravity, near Earth's surface,
Okay, who wants to keep watching? Right, so that's what Khan Academy is, and it's basically like reading a textbook, or more, it's like having a textbook read to you. And it's a great resource, it really is, if you are in a place where you don't have access to a textbook or to a university course. But in terms of getting people to like flock to your stuff and be excited about it, I don't think so. So that's Khan Academy. Now the next one I'm going to talk about is RS Animate. They do these great, really complicated-looking infographics to TED Talks, or similar kinds of talks, TED Talks that I talked about. So I'll play just a quick clip of one of them.
Okay, so we've been through this crisis, and there are all sorts of explanatory formats out there, and it's interesting to look at the different genres.
Okay, so that's enough of that. I think you already have seen enough to get the sense that that RSA has a problem of labeling what you see, and it's kind of the cardinal sin of you don't want to read directly off of your slides. Sorry. And to me, this is a fatal flaw in kind of video creation, because like the pictures are really cool. You go to a museum and you see these really cool pictures.
I hear that old
Maybe
piano from down.
A really loud radio. But okay, so I'm not giving RSA enough credit. They have songs or sounds that at least are somewhat appropriate to the stuff at hand. But that said, film is an audio-visual medium, and you need the audio parts to actually integrate with the video part and not just kind of smash them together. So to put this in terms that physicists can understand, suppose you have two forces that you think are somewhat related. What you do when you want to make them into a single force, you put them next to each other and draw a box around it, right? No, you don't do that, actually. So that is that's my view of RSA. And when I look at my videos, when I'm creating them, sometimes I will notice that there is a single shot or slide or whatever that exhibits what I call the RSA effect, which is where the slide literally just writes down what you're saying. And I don't think that's useful at all. Like, I would rather just listen to it and not have to bother reading it and hear it read to me. Okay, moving on. Stanford this fall had this amazing artificial intelligence course advertised. And it looked really, really cool, and I was really excited because this summer I got really excited about AI for a little while. And I really wanted to take it, and they were going to be doing this great new thing where it was going to be on the internet. It was going to be like homeworks and tests, and they were going to have lectures available. And it was supposed to be very innovative. And I watched the very first lecture on whatever, October 10th or 11th, and I was pretty crestfallen because it was kind of like watching Khan Academy. And I thought that they put a lot of effort into all of the infrastructure around the course and into advertising the course and promoting it. And then the actual course itself was just like watching a lecture videotaped of the university. And now I can't say that's for the whole course because I didn't watch the whole thing because I was bored very quickly on, but it became clear to me that they had missed a wonderful opportunity to actually do something innovative here. And so and this is one that less people have heard about, and this was actually after I did Minutephysics, so I had been thinking about this sort of thing for a while. And I really was disappointed because I wanted to learn artificial intelligence in a really cool, creative way. Okay, so the last thing I want to talk about in terms of these Tour de Science videos is Perimeter's own Alice and Bob. And they're created by the outreach team, and I think some of the outreach guys are here, so I don't mean to like go into full analysis, but it's really, I think it's important to like talk about this stuff scientifically and try to figure out what is going on with these videos. So first, I'm going to play one of the videos. Let me say one fact about them is that I was talking with the outreach guys this morning, and they said that they had just put them all up on YouTube, all as a bunch. There are like 9 of them, sometime in the last year or two. And just kind of let them sit there. And I think by this point, some of them have gotten about 1,000 or 2,000 views. But they didn't really, they didn't accelerate anywhere. And I think I know some of the reasons why. Let's watch one first, and then I'll talk a little bit more about that. Let me make sure this isn't too loud.
Hey, Bob. I this tree can exist.
Well, a seed fell, then rain and sunshine came along.
No! I mean, a tree is made of atoms, and I don't see how atoms can exist.
Why not? Electrons orbit the nucleus like planets orbit the sun.
But that's impossible. An electron is charged. Moving like that, it would give off light.
And that would drain its energy, causing its orbit to spiral in.
Right. All the atoms in this tree, in the whole universe, should collapse in a blinding flash of light.
Whoa.
I think we're gonna need more powerful ideas to understand how atoms can exist. Maybe quantum ideas.
All right, so that's Alice and Bob. And one of the very first things that always accompanies Alice and Bob, at least when I'm watching it, is somebody else in the room saying, "Put on headphones, that girl's voice is really annoying." And you know, some people may not think that. Like, they're very well produced, I have to say. Like, they're incredibly well produced videos. But if everybody who hears the girl's voice thinks it's annoying, it's a problem. And so that to me is the very first striking thing about them. The other thing about them, in terms of the video content themselves, is, you know, and they're very clever videos. I think one of the issues that I have with it, and maybe this is just a personal thing, I feel like the goal of them is to get people really interested in the physics, but they don't, like, there's not a whole lot of teaching going on in the videos. It's much more of like a grabbing out and saying, "Come and let's watch more." And I think that is, you know, it's a valid approach to do, but then some of the question is, well, what's next? Because there needs to be something for them to be connected to. And there's a little bit of teacher outreach material, I believe. And we were talking about ways of improving this. I was talking with Rich this morning. The other thing about it is that you have to know a little bit about the way YouTube works and the way you build an audience. And you don't build an audience by putting, you know, 10 videos out and letting them sit there. What a better way of doing that, of building an audience, is to put out one video and, like, send an email to some friends or to some science bloggers or whatever and say, "Hey, check this out. You might think it's cool." And then another week later, you put out another video and do kind of the same thing. And maybe some of those people liked it and they subscribed and they'll get notified when your new video comes out, and it kind of grows. And you do it, you know, for 7 or 8 or 9 weeks. You remember the graph that I had of Minutephysics, you know, down along the bottom here? It took a long time before it started going anywhere. But you're basically building a relationship with your audience, a commitment to them, saying, "Look, I'm going to create this content that you like, and I'm going to give it to you, you know, week after week, and in return, you're going to watch it and enjoy it." So, and that's one of those things where if you just put out a whole bunch of them all at once, which I know that the goal at the time for Perimeter was not to, like, make a big YouTube channel. It was kind of just to have them online so people could watch them. But if you're going to try to have them watched by a lot of people, it helps to have a strategy that you're going to follow to do that. So now, moving on, there's one last thing I want to talk about, because Alice and Bob is really well produced. But I don't know if you noticed that the RSA videos there's some really good drawings, but the production quality is a little bit lacking.
If anything, it's the excessive power of capital, and in particular the excessive power of finance capital, which is the root of the problem. Now, how did that happen? Well,
so you notice there were some little gaps in the audio there. The audio quality itself is pretty bad. It's probably recorded with a microphone like the one I'm wearing at a talk like the one I'm giving, which it makes for, you know, good quality content, but the sound doesn't sound quite good. When they cut it up and leave those periods of silence, even though you may not explicitly notice it, it distracts you. It takes you away and you step back from the video as a whole. And what it speaks to is the fact that they are having difficulty fitting these huge, complicated drawings into, like, 2 words of the guy's speech. And what they really should have done is figured out how to draw it without drawing all the stuff and fit it to the speech. So in a similar way that, you know, Alice and Bob have good production value, and PI's, there's the Quantum Tamers, has a very high production value. I'm going to take another look at another video that has series that has good production value, which is Brian Greene and his work with PBS and Nova. I think the most recent one is called The Fabric of the Cosmos. I'm going to show you a bit of the trailer to give you a sense of what that is about.
Lying
just beneath everyday reality is a world we hardly recognize. A breathtaking world where much of what we perceive about the universe is wrong.
What if you took all this stuff away?
A world where the void of space is not nothing, but something. A world where time can bend and flex.
Why do we only see events unfold in one direction? Why don't we ever see them happen in reverse order? According to the laws of physics, this can happen.
Okay, so that's kind of a little picture of what Brian Greene does. I'm just going to show one last little bit, cutting later into the trailer.
It's a vision of the cosmos grounded firmly in science, but one that stretches the imagination.
Is the three-dimensional world an illusion?
What is space? We actually still don't really know.
This looks familiar. Now, I think they probably threw more money at it than I did. But yeah, it's not a particularly new way of explaining physics, and also they both of them and I chose a horrific coordinate choice. But anyway, this is really shock and awe science teaching. It's intimidating. It makes it feel inaccessible because when the scientists themselves, who are the supposed experts, say quantum mechanics, no one understands it. That is not a great way of trying to convince somebody they should make an effort to understand and learn quantum mechanics. So, you know, it's kind of like this this bit of, I think this is from A Serious Man, of how do you teach physics? And so, this is movie magic, you know, movie magic. But anyway, I'm going to talk a little bit now about teaching physics and some thoughts that I've had about teaching physics from doing these videos. So to start with, we're going to talk about special relativity. And before I show anything else, I would like everyone to close your eyes for a moment and picture special relativity. What does SR mean to you? What pictures, you know, what drawings would you have in mind? What equations? Write down on your paper in front of you, you know, how you view special relativity. So, everyone got it? Now, did anybody draw this picture? Or this picture? Or did you write down this equation or these sets of equations? This is all like the top 5 hits on Google, by the way, for special relativity. You know, I bet, did anybody actually write any of this stuff down? Raise your hand, don't feel ashamed. Okay, no one did. Now let's see if I can guess correctly what you did write down. Did anybody draw this picture? Or write down something that looked like this? Or if you're really clever, you might have just done that. But you know, the question is really like, why do we think about special relativity in this beautiful, simple way, and then teach it to first-year college students as a horrific set of equations? To me, this is just mind-boggling. And I feel, when I think about this, I almost start to feel offended that like this still goes on, and that people who might find the beauty in physics are like, don't have the opportunity because they get pushed away. And I think what a lot of this comes down to actually is that physics has this love affair with history, and math, for example, in contrast, math doesn't. Math is like theorems are like an ivory tower, and you have no clue where they came from. And all of the scaffolding has been removed. Physics, on the other hand, may be slightly obstructed by our insistence on history. And don't get me wrong, knowing where stuff came from is really important because it helps you move forward in thinking about physical theory. But if you're trying to explain, you know, something to somebody, the question is, why would you teach physics the way it was discovered if you can teach it the way it's understood? And I think that a better approach would be to do something that's a little bit more integrated, where you can see the beauty and the simplicity of the physics and still get a little bit of the scaffolding in there as well. You know, where did it come from? So moving farther in that, in terms of actually the actual method of teaching, I want to talk a little bit about analogies in physics education, and actually in education in general. You may have noticed that my entire talk has been basically a series of analogies about things. And I used analogies to explain YouTube videos in physics terms and explain physics things in YouTube terms. A lot of people say that analogies are poor because they're never perfect. Math is what's really behind the science. But what about the people who don't have the time or the energy to devote to learn all that math, and the people who do other things that help us as academics exist and not have to like farm for food? So the question is, if there aren't perfect analogies, why do we use them at all? And I think that this comes down to human nature and the fact that humans really have to understand things in relative terms. We have to put things in terms relative to something we already know and already understand. And if people are going to do it anyway, it probably makes sense for you to do it, for somebody who's knowledgeable about the subject and has an idea of a good analogy to do it, rather than let somebody come up with a super wrong analogy. So now that said, I think that we also need to be clear that an analogy is not science. If it's perfect, then it's probably, you want to write it down as a physical theory instead. But a lot of people who write articles for this place, the Vixra, and they normally use Microsoft Word to write their articles. They use, from the ones that I've read, and I think people often get articles sent to them as well by kind of pseudoscience articles. A lot of those try to use analogies for everything, and they don't ever go into the physics and the math. So my take on that is that we really need a meta-analogy, and to explain why do we actually talk about, how do we talk to these people, and how do we teach physics in general? And so I think about physics in a lot of ways, and the math as like a Chinese poem. And we're the Chinese poets, and we need to, if we're going to teach people about physics, we need to translate it into the language that they're going to understand. And so, it's not going to be perfect. No translation can be perfect. But you want to try to go for the essence, and what is it that you really want to get across? What point do you want to teach people in order to both educate them but also engage them? And this also happens to be a really good rebuttal to those guys that think they have really good ideas for like grand unified theories of everything who write with Microsoft Word. Because you can tell them, look, if you're going to say that you've written the best Chinese poem in the world, you better learn Chinese first. So I also happen to think that we need a lot of new analogies. I think a lot of analogies in physics come from limited sources, and we kind of just stick to the ones that work. And everything these days is a wave or it's a particle. So as wonderful a man as Richard Feynman was, he's been dead for 30 years, and I think there's been some physics that's been done in that time that needs explaining. And probably some of the stuff that was done before he died also needed explaining. He didn't get around to coming up with ways of doing that. So I think we all need to call upon ourselves, really, to come up with better ways of explaining things to people who don't understand the math and the physics, or even to your colleagues who don't know the nuances of your field. And so this brings us to kind of the final point, the grand unified theory of YouTube videos, but you could also call it just the grand unified theory of communicating science, where you need to know and respect your audience and know what they're bringing to the table and what you need to bring to the table. You need to choose valid content. Don't talk for 10 minutes when you have 1 minute of things to say. And you need to use your medium to its full potential. You remember when I was talking about RSA, you don't want to just slam things together and call it a day. You want to make it look nice and pretty. So, and really, you want to actually unify. We call this unification in physics for a reason. It's not just slamming things together. So if you're doing a talk, it doesn't have to be a video. It can be a presentation. Here's the audio. There's the visual. They need to be unified in some way, and not just reading, oh, that's SU2 cross U1. And now we can actually draw a box around it. So the other thing that is important, it is slightly less important, but I believe it's important, and especially to success on things like the internet, is you need to have a quality in your execution. And it needs to, things need to sound good, they need to look good, it needs to be clear, no typos, that sort of thing, I think is really important. Because those things, while they may not be necessarily detrimental to what you're talking about, they just distract people. And distractions, anytime you're communicating, distraction is bad. So really, I think the takeaway message from a lot of this as well is to be your own Feynman, be creative, be crazy, but be good at what you're doing. And now, just to finish things up and wrap it up, I want to show what is one of the minute physics that I really like, and I think is the only minute physics that I've done where I've actually come up with an analogy that I didn't know before. It's the only original one, in my view. And so here, hopefully the sound will be loud enough. Enjoy.
What do we really mean by near and far? In a way, distance is just a measure of how hard it is to get between 2 points. The harder to get from here to there, the more distant there is. This makes thinking about distance in multiple dimensions easy. In 2 spatial dimensions, a point a mile north and a mile east is more distant than one that's just a mile east. It's harder to get to. What about 1 space and 1 time dimension? Piece of cake. Getting to a point a mile east in a minute is a lot harder than getting there in a day. So 1 mile east and 1 minute in the future is way more distant than 1 mile east and a day in the future. And a point that's a mile east right now is impossible to get to, so it's super distant. But hold on, that would mean that a minute is farther away than an hour. Doesn't that seem backwards? It kind of is, but that's the way the universe works. In special relativity, more time equals less distance. So distance in time is negative. And if you travel east and into the future in such a way that the negative time and positive space distances cancel out, your total distance will be 0. And you'll be traveling at the speed of light. So how far away is tomorrow? It's closer than you think.
Thank you very much.
I'm sure we have some questions, so besides students first, as usual. Go ahead.
Yeah. Okay. When you talk about like relevant content, that's kind of tricky because like there's a lot of outreach in science sometimes, and well, I mean sometimes they make really strong claims that can confuse people. Like try to explain some of the most advanced things in physics in terms that are so simplistic that people end up being really confused. And I don't like, for example, like, no offense, but like string theory is one of the famous things because you see it in like Discovery Channel every day or something. Yeah. And they have this really strong like, oh, we live in an 11-dimensional universe, period. So some people just get confused because they say, oh, this is a scientist on physics.
Yeah, actually, that's one of the things like I have very much shied away from doing anything on string theory yet because I'm not sure how to approach it. And I want to make sure if I approach it, I do it in a good way. And that is one of the issues of doing science outreach is that you need to present things in a way that sounds authoritative, but somehow still get across that it's science and that things may, eventually be shown to be slightly different from what we expected. They're not necessarily wrong, they're just not 100% right. And I totally agree with you. And I think that there's a lot of place in the media where the media will jump on things that sound really cool just so they can make it, make a quick, easy story. And if you're gonna be part of the science media, you need to try to avoid that. At the same time, it's very seductive to try to jump on that bandwagon and do things. But the only one that I've tried to do with this is the Nobel Prize one and that was just luck that happened to have already had that recorded. You have a question?
Who's your audience? I mean, who are you aiming to educate? Like, are you aiming to educate like high school or middle school, or like people just who are going to decide how much funding you're going to get?
Well, I mean, the funding is decided by how many people who watch the videos. So ultimately, I would love to be able to have these videos understood at some level and be entertaining at some level for anyone from probably middle school through 50-year-old, educated in science, uneducated in science. And from the kinds of responses that I've gotten on YouTube, I think that it's moderately successful in that. I have people who, like Tibro, who likes to watch them, and people who are 13 years old and don't know anything about physics and math who also like to watch them. And I try to put little things in there that, it's kind of like when you watch the movie Shrek. It's a kid's movie, but there's a lot of adult stuff in there that people don't notice until you're an adult and watch it, right? There's all these innuendos that you don't get when you're, 13 years old, or The Lion King. Well, I don't know how old people were when they were watching these movies, but in the back.
Hi. Do you have plans, or are you supporting the YouTube channel with any other support materials in terms of providing? Like, do you have a blog that people write in and have more questions about each?
So I have my email on the YouTube channel. There's a Twitter, Facebook, and a Google+. I don't have a blog. I don't have time for most of this stuff because I'm also a full-time film student. YouTube is one of the things it's worst at is actually linking to things outside of YouTube. And there are ways of getting around it, but you have to have a really good reason, and you have to know somebody inside YouTube to do it, to link directly from the video. If you want to link from like the description, that you can do that, but it's really like no one reads the description, so it's hard. Unless you literally say in the video, links in the description below, click on them to find out more. I think it would be great to kind of connect some of this stuff with larger materials. What I normally have kind of had to resort to doing these days, if people write with more questions, if it's a simple question, I'll answer them. If it's a complicated question, I normally kind of point out some places like Wikipedia or other articles or other blogs, because there are working physicists, plenty of them, who also write blogs and explain these things in great detail as well. Did I answer your question?
Yeah, yes, but in the future, are you planning a little bit more support or not?
I would love to be able to figure out how to do it. If I had more time, I would try to. And people have, I've had people, had some publisher want to approach me about doing a book where you have pictures from the videos, and then you can actually go into a lot more detail. Obviously, that's not directly associated with the videos. And it's one of these bizarre things where, if YouTube videos could link directly to outside things, it would be so much easier, but they can't. So I have to figure out a way to work around that. Yes?
How do you determine how fast you're going to present the information? Because I know you're limited by a minute or a little bit more than a minute. But I know that as a non-scientist, I was having trouble processing and thinking about the information that was being given. And so the question is, how do you determine pauses and time when presenting information?
One of the best ways of doing that is I show it to my roommates who aren't scientists and ask them what they think and whether the places that they felt lost. Another thing that a lot of people say about it, and I don't know if this is a flaw or a good feature, but people sometimes will watch them twice or 3 times because they can get more out of it or they can get it in doing that. You might say, well, why don't I make them 3 minutes long then? But I feel like part of it is the fact that it is kind of dynamic and fast-paced, and if you slowed it down, it might become more like Khan Academy, and people would stop being interested. So, but it's definitely a good question, and it's something I struggle with because obviously I can't step back from it and look at it in a critical way, unless it's really, really, a really flagrant problem.
Very nice talk, Andy. It's good to see you. Just a couple of comments. There's one thing that always irritates, or several things that always irritate me about science presentations when I see them in popular context. One of them is music in the background. When a poet is talking, or when an economist is talking, or when a politician is talking, they don't have music in the background because what they have to say is assumed to be significant, and you don't need to be entertained at the same time that we're talking about something important. And whenever I turn on the TV and see some program about science, there's always jazz and music and something in the background. I like the music very much, and I find that really irritating because I want to listen to the music and I stop listening to the science. Or I'm listening to the science and then I'm frustrated and not listening to the music, but I can't do both. And I take this as a kind of denigration of science. It's sort of, science is really boring unless we add music to it. Okay, which I don't like. Okay, that's one issue. Second thing is, partly what Jesse said, is the fact that when there's something really interesting to watch, it often is jumping around too much. For example, if I look at a Weather Channel program about a tornado, I think tornadoes are absolutely fascinating. The fact is they're not understood. Nobody really understands how they work. It'll be really interesting to see a continuous film of a tornado lasting for, say, 3 minutes or 2 minutes, and watch it evolve very slowly. Okay? But you can't. When you turn on the Weather Channel, it goes, bzzz, that's it. It's cut off. Just when you're really getting interested, it's cut off and it jumps to something else and then it jumps to something else. It's very frustrating, but that seems to be the Sesame Street pace at which things go. So I'm speaking from an old school, okay?
Right.
But personally, I find that way of presenting things very frustrating, and it doesn't happen if you have a program about economics or poetry or history. It doesn't jump like that. So there's an implicit statement of, I apologize for talking to you about science. I have to keep jumping to keep you interested.
My response to your first part of your question is, if you look at, say, the latest Hollywood blockbuster, they probably play like music behind Halle Berry, and she should probably be interesting without music. And music, and I can sympathize with you because I, as a musician, like I get just very distracted by music. Like I can't work with music on. I have roommates who listen to music all the time. I cannot work with music on. I get distracted because I want to like listen to the music and play along with it. But at the same time, music is one of those things that can really unconsciously kind of tie things together in a way and give something a tone that doesn't have otherwise. And one of the best examples of this was actually when I showed one of my videos to one of my roommates, and he watched it and said, I don't know, it doesn't really feel right for some reason. And I played it back to him again with the music, and he said, oh, well, what's different? It's just so much better. He didn't notice the music was even there. He's not like you or me. He doesn't notice these things, but he felt different about it, and he felt like it actually had this a certain tone to it. But obviously, it's an issue, and so I try to keep the music kind of lower. It's also really hard because with the bass just is at the low frequency end. On speakers like these, it can be really loud, and on your laptop, you won't hear it at all. So I recommend you watch Minutephysics on your laptop. And an answer, let's see, your second question, Neil and I were actually just talking about this morning, doing longer versions of these videos. So hopefully that will be in the works. Yes.
So to what extent do you think it's important to make these videos self-contained, and to what extent can you have the next one build on the last one?
I think that they should be each one should be self-contained as a story. It may require information from previous videos. I don't want to go to the extent that might be done in Khan Academy, where it's like you can't jump in the middle and understand anything, right? On some of those, you really have to have watched, like, I don't want people to have to, in order to watch this video, they have to watch these other 10, because they're gonna just not watch them. And it'd be better to have somebody watch this video and get excited about it, and then go back and watch the 10 because they're excited about it. It's a tricky thing to do. All of this is really, I struggle with a lot of it because it's really hard to boil these concepts down into a minute. Try to make them accessible to people who don't know any physics, and entertaining people who know way too much physics, and then have them stand alone. To some extent. But one of the big reasons to have them stand alone as much as possible, and they can possibly link to other things, but a big reason to have them stand alone is because of the way that YouTube and the internet work, is that people will very often see a video they like and send it to their friends. And those friends will not have watched the other ones, even if this person has. And that's the way that videos, normally on the internet, single individual videos get big, and each one helps the underlying kind of network or the channel get a little bit more growth. So unless you're really lucky, I don't know who it was at YouTube who liked my videos, because they put 4 or 5 of them on the front page one day, and the very top. But normally there'll just be one video of yours, every once in a while, that gets really, a lot of views. So that's just from a purely that's just because of the way the internet works.
Can I ask a question?
Yeah.
Describe a little bit about the demographics of the people who are watching.
Oh yeah, so the demographics, it's about 80% male and 20% female. I don't actually know how that compares to the internet as a whole, but, and then on the male side, it's pretty much flat. There's no bump. People expect there to be from the, 17 to 35 to be the main demographic. On the male side, it's flat until you get to about 50, 55 years, and then it just kind of drops off. Which I think is interesting that people are interested across all ages on the male side. The female side is also flat until 55, except for the 13 to 17-year-old girl range is twice as big as any of the other ones. My first interpretation is that that's the biggest demographic on the internet of women. So the question is, I don't know the exact numbers, so I don't know whether there are more girls watching these than average on the internet or less. So I need to look into that and figure it out. But it's interesting that it's flat across everything except for those young girls. And Neil and I talked about this and the potential that maybe young girls are interested in physics and something that goes on as they go through college or whatever turns them away. Rob?
Just wanted to ask for your opinion about the future of higher education in the internet age. So supposing that your audience was not, the public at large, but you wanted to teach a course, in depth on some topic, like introductory quantum mechanics. And so you have a smaller audience in mind, people who are going to be committed to playing that. So you talked a bit about what didn't work with the artificial intelligence course and the problems with the Khan Academy approach. But I just want to hear your thoughts on, what do you think would work? Does 10-minute segments work? But what are all the ingredients that you think would make for an ideal course on the internet?
I think one of the biggest things, and something that maybe people aren't utilizing enough on the internet, is the interactive ability. And it's really like, that's what you get in the classroom, is you get to talk with people. When I was in the Sci course, a lot of our classmates, by the end of the year, they weren't coming to lectures and they were just watching them because they're recorded. And I would always want to come into the lecture because I want to be able to be there and ask a question. And be taking part in what's going on. So if there's some way of getting that same environment across on the internet, obviously a big part of learning is not just being told stuff. And videos, by their very nature, are telling people things. And so I don't really think that stuff like Minutephysics by itself has a huge role to play in the core of the future of higher education, because people need to actually sit down and work through the material themselves. It can be a really good kind of primer or intro, and other videos of similar style I think can potentially help in terms of like lectures. But when I've found lecture courses to be most successful is when they've had the most work outside of the lectures that we had to do, whether it be tutorials or homeworks. Like in college, for me, most math and physics classes had one problem set per week, but you have 3 lectures per week, so you really kind of miss out on a lot of the material. And the courses that I learned the most in were the ones where we had a problem set due every single class, and we had a problem set for every single lecture. And the same with Perimeter. When we had like tutorials after every single lecture, you actually start to work through the material yourself and figure out, you need to find your own understanding of it. So the big answer, I guess, is I don't know how, but I'm definitely trying to think about it. And it's going to involve some sort of integration of all sorts of different things. It's not going to be just videos or just chat rooms or just this or that. It's going to be some sort of clever integration of everything.
If you don't mind, I just wanted to say something about what you were talking about with the Stanford AI class. Is I feel like even if they didn't hit on, say, the correct use of video or the correct use of lectures, they really, and I don't even know if it was on purpose or by accident, hit upon something very important that I think is an essential component of what Rob was getting at, and that is the use of social media in such things. Like I remember when I wasn't taking the class, but while it was going on, like there would be days where there would be a homework assigned, and the majority of my Google Plus feed was people talking about this homework and like sharing, lists of other people in the class who had gotten this part of a problem and had a brilliant way of explaining it to everybody else. And it was, to some degree, I felt almost like I was a part of the class just by osmosis, because it was decentralized in such a way, people were using these tools to communicate about the class. And I think that's a very important aspect, infrastructural perhaps, but still something that they got very right.
Yeah, so that's maybe one thing that I kind of glossed over with what they did, is they had a very good infrastructure for the courses, and they had with the homeworks and the tests and all the stuff that you were supposed to do for the course. The big thing that struck me was that the videos seemed very disconnected from that. It wasn't very well integrated, and the quality and appearance of the rest of it was very good. And then you saw that the logo they had was really professionally designed, and everything looked very nice. And then the videos you got were not so nice. So, and I totally agree with Chris that social media, basically it's the same as having a discussion. It's like when you go with your friends or classmates after class and study your work. So the question ultimately I think is going to be is it more productive to study with other people on the internet or with other people next to you?
I don't know if it's a good question or not, but I'm curious to know if you can earn money, I mean, doing Minutephysics.
No, it's a very good question. I ask myself that a lot. Yes, you can. YouTube in general, you can. They have. If you see a video with ads on it, the person who uploaded that video is making money off of it. It's not very much compared to like cable TV. Like the companies don't value, advertising agencies don't value the internet as much as they value things like television. Hopefully it's going to be moving along and getting more lucrative on the internet. I wish that it were more lucrative because then I could have less videos with ads on them, because I think the ads can get in the way, but at the moment it's a way of me being able to continue doing this and justify doing it while I'm still a full-time student. This is my part-time job outside of school.
How much time does it take?
I've been telling people on average like 12 to 14 hours, but really the biggest, by far the biggest and longest part is writing the script and figuring out what I'm going to say and how I'm going to approach these topics. And sometimes that will be like I'm riding my bike and I'm thinking about something, and I suddenly have an idea of like, oh, that's a way of explaining it, and then I have to kind of develop that as like I'm cooking dinner or whatever. So like there's these things that I don't count in the time of 12 hours, but like the 12 to 14 hours is really like sitting down and writing, and then all the rest of the production of it, and including like putting it on YouTube and doing all the nonsense that you have to do to connect it to all the social media that takes a lot of time, but it's crucial. You have to do it. Yes.
What's next for Minutephysics, and might you have any other science communication projects brewing or forecasting?
Yeah, I've been thinking about a lot of things. I've been talking to Neil about some possibilities working with Perimeter. I would love to be able to have time to branch out and do other areas of science. I'm particularly passionate about climate science, ecosystem science, and earth science, that sort of thing. That's Minute Earth, basically. It's kind of what my next goal would be, to do something like that. And I've been talking with some people from YouTube, or who used to be at YouTube or now running their own company, about how to start kind of a broader network of things. So if anybody here likes to draw, or likes to write, or likes to boil topics down in some area, maybe math or something other than physics, because I feel like I'm working on that a lot. I'm looking for, or if you know people, like I'm definitely always open to people who want to do this kind of thing, or even to at least take a stab at it. And you don't have to be able to do everything. If you can write, that's great. If you can, draw, that's great. If you can do the social media stuff, that's great as well. So ultimately, if this gets bigger than just me sitting in my bedroom, which hopefully it will, then it'll require a lot more input. Because one of the things about Khan Academy is really he does almost all of it himself, and it's amazing how much he's produced. But it's because he just sits down and reads out of a textbook basically. So I'm hoping to, if it expands, I want to make sure that like it all is still of the same kind of quality.
Can I make just a brief comment about climate science versus teaching other science?
Go for it.
The difficulty with teaching climate science is that you have an opponent who's teaching anti-climate science. If you're teaching fundamental science, you don't have an opponent. There's no one who's presenting material that contradicts your material. Climate science is a particularly difficult science because it's fraught with politics. And in fact, the opponents have made fantastic progress in the last just about 1.5 to 2 years. If you go back to 2 years ago, the number of people who believed that climate science and the Earth's climate and so on, this is a very serious issue, was on the order of 70%. And now the number of people who believe that it's
in the U.S.
It's in the U.S. Okay, and the number of people who believe that the climate issues are serious is well below 50%. There's been tremendous progress in the people who are anti-educated. So if you can make progress, I would be fantastically delighted.
I'm very aware of all of this sort of thing, and my father is in fact a climate scientist. So I've been thinking long and hard about ways of doing it without, because there's the balancing act of, do you try to be like tiptoeing around because you're worried people are going to yell at you because it's political, or the value of saying, look, this is hard science, this is just as real as the theory of electromagnetism, the theory of general relativity, and just sticking it out. And so I think that those are people who do climate science, both research and media coverage, have to grapple with that all the time. So yeah, I'm very wary. And if I'm going to do it, I'm going to figure out the best way. So if people have thoughts on that, please let me know. Yeah.
So to get specific though, and maybe not as political, have you ever done a video, a Minutephysics video that overlaps with an Alice and Bob video in terms of the topics that it covers? And could we use that as a case study to see what's different between the two approaches?
I'm trying to think if there are any of them that overlap.
There was.
I mean, there's
the ultraviolet catastrophe.
Yeah, there's a gravity one that they do, like wasn't the moon fall down? And I did a gravity one, but I talked about it in slightly different, in much more general terms. I'd have to think about it because I don't have all 9 Alice and Bob videos and all 20 Minutephysics videos in mind at once. But I can think about it if you want to look at that. So we can come up after and use the internet.
Look at YouTube videos? Yeah, I meant.
Okay, last question from somebody.
If you don't mind a second one, I just wanted to make a suggestion for your taxonomy of science and YouTube videos. Is that there's more than, I think, just science education. There's also the broader goal of science outreach. And I know personally, like, I've seen a lot of success with the Symphony of Science videos, which don't try to teach even slightly. They're just beautiful music that is made from sampling, say, people talking about science. I mean, if you've ever walked down the street listening to have to make an apple pie from scratch. But anyway, but that still is, I think, a very valuable part of doing science outreach, is to say, you know what, let's just make something where we
appreciate the beauty of the world.
Yeah, and I mean, it's not teaching moments, but it's still very valuable.
And I think that sort of thing is more about teaching people to look around them and be curious, even indirectly. Like if people are amazed, can kind of get an appreciation for how amazing the universe it really is, or how amazing life really is, or how amazing the fibers in this carpet really are when you look at them. Yeah. I think that's the sort of approach that you really want to go for. So yeah, I think that's the thing that's great as well.
Good. Let's thank Henry again.